Hi, so I'm doing my video on electric potential. So what is electric potential? It is defined as the amount of work needed to move a unit of charge from a reference point to a specific point inside the field without producing an acceleration. We know that um, when a force acts on something and moves it a distance, there is work done on that force. By the equation work equals force times distance. And we also know that the work done is equivalent to the change in something's potential energy. So in this case, the work done on a particle is equivalent to the change in the particle's potential energy. For me, it is easy to understand electric potential when I compare it to gravitational potential energy. They are very similar, just different forces causing them. Obviously, gravitational potential energy is caused by gravity, and electric potential energy is caused by electric field. So, for example, if we have a ball on Earth and we move that ball farther away from the Earth, as we get higher and higher, the gravitational potential energy increases. We know this from the equation for gravitational potential energy, which is mass times gravity times height. So as that height increases as well, the gravitational potential energy will increase as well. And in the case of the electric potential energy, if we have a positive charge and the source is creating the electric field is a negative charge, and we move that positive charge away from the source, we will be creating an electric potential energy. Um, Now, in both cases, say for the ball, we drop the ball, it will accelerate towards the source, and this will be the same for the point charge. If we were able to pick up the point, move it away from the source, and then let it go, it would accelerate back towards the source because the opposite charges attract. We can also calculate the potential energy per unit charge by dividing the potential energy by the charge of the particle Q, and we get this equation, the volts equals potential energy divided by Q. We can calculate voltage at the volts at different points to find the potential difference. And that's where we get this equation, the change in the potential energy divided by Q. And then the units for potential difference are joules per coulomb, and this gives us the unit volts, which we will use a lot when dealing with electric potential and other things.
So Khan Academy has a video that I think is very helpful in understanding electric potential. Basically, electric potential is an abstract idea associated with points in space. So if we have these points in space and there's no charge, the electric potential of these points in space will be zero. However, if we add a charge, which is the Q, um, these points in space will have an electric potential. The points in space closer to the charge will have a larger electric potential, and the points in space farther away from the charge will have a smaller electric potential. So in this case, over here you can see we have this point in space, there is an electric potential of 100 joules per coulomb. So if we have a charge that is a 2 coulomb charge, to find the potential energy, we would just have to multiply the electric potential by the charge, which would be 100 times 2 in this case, and it would give us 200 joules of potential energy. So I thought this was a very helpful way of understanding it. And now I wanted to go and do a few practice problems. So here we have our first practice problem. And like it says, an electric field exists such that there is a 6 newtons per coulomb force in the y direction. A proton is moving from the origin to the position y equals 10 meters. What is the change in electric field? So I first like to figure out what variables they give us. So in this case, they give us 6 newtons per coulomb force, so that is a force per charge. And then they also give us a distance traveled of 10 meters. So now we need to come up with a formula that could use these variables. And we know, as we discussed previously, that the formula for potential energy, for electric potential, is the change in V equals the change in PE, or the potential change in potential energy, divided by the charge. And then we also know the formula for the change in potential energy is equal to the force times distance. So if we plug that into the original equation, we will get the change in V equals force times distance divided by Q. Well, force times distance divided by the charge. So in this case, they give us a 6 newtons per coulomb force. And so 6 newtons per 1 coulomb, so we can kind of ignore the charge at this point. Take that 6 and then multiply it by the distance, which is 10. So 6 times 10 would give us 60 volts is the change in electric potential. The next problem reads, a negative charge moves through an electric field such that it slows down, losing 100 joules of kinetic energy. The change in electric potential experienced by the charge is negative 10 volts. What is the magnitude of the charge? So for this one, it's a little bit trickier, but not too bad. We also I like to first figure out what we have. So it gives us a change in kinetic energy. It says losing 100 joules, so that's negative 100. And it also gives us the change in voltage is negative 10. So now we need a formula with all these variables to help us find the magnitude of the charge. So we know that the formula for the change in potential energy, or the electric potential, is change in V equals change in PE divided by Q. And so here we have our change in V, which they give us, change in potential energy, which we know that if kinetic energy is losing 100 joules, then potential energy would be gaining 100 joules. So we could plug in 100 for that, and then the charge is what we're looking for. So we plug those in, we have negative 10 equals 100 divided by Q. So to find Q, we need to know basically 100 divided by what equals negative 10. So we know that if we divide 100 by negative 10, we would get negative 10 as our answer. And so it is asking for the magnitude of the charge, so the magnitude of the charge would then be 10 coulombs. So that is all that I have prepared, and I hope you guys have learned a little bit more about electric potential.